good sign that I have, but, you know, I've been writing books since then. And it was really only the sort of discovery that there seems to be a paralysis in the cancer research world against thinking. I mean, you know, it's too specialized. Everyone is so specialized. They just don't know the whole thing. And, you know, we thought, well, it would be a really good use of just write a good, simple book about cancer, where you try and put a little theory in instead of just facts. I mean, Bob Weinberg's a great book, but no mention of glycolysis, lactic acid, or Farber. How can you write a book about cancer and not mention Farber? Well, Bob did. So, his day is gone.
So, Jim, you stopped responding to your comments about targeted agents. And
yes.
I think we both agree that the cost is hard to defend.
Yes.
But I think philosophically, I think targeted agents still are the future, whereas I think you're sort of starting to sweep them under the bus a little bit. And I think, in fairness, I would argue what we're seeing now with targeted agents used as single agents is precisely what we learned or experienced trying to treat AIDS with single agents or TB with single agents. So I like to think we're on the right road, and I would think as a geneticist you would welcome these genetically validated targets such as RAF and ALK in lung cancer. But you know, I think a lot of people in the room might have taken away the idea that that's a mistake.
Well, I think in many cases you've got to kill the
Use the mic.
You have to, yeah,
Use the
yeah,
mic.
sure. That they're going to stop working when reactive oxygen species, antioxidants build up. So that we'll see with time whether their time of action whether their action is independent of the arrival of antioxidants.
Okay, well that may or may not be true, but my conjecture is we'll come back to the same rule or set of rules we've learned for AIDS and TB, and even those cancers which we cure, which is once you can start to combine several agents that are not cross-resistant, that have distinct mechanisms of action, you can overcome some of these resistance problems, which I think were quite predictable.
We can try, but my hope is, you know, to get my point across, I exaggerated, and I have to agree with you. But, you know, I would hope more from mTOR drugs.
Well, no disagreement. Then, you know, the other point is, I mean, I sat in this room in the 80s and listened to lectures about some of these same ideas. And there were clinical trials where people tried to, for example, block antioxidants, and so far they just didn't go anyplace. So I think this is an intriguing set of ideas, but people have thought about it, and so far no one's been smart enough to figure out a way to drive it into the clinic and make it work. But drugs like BSO did go into the clinic.
Yes.
Others may have something to say here, but and then the last thing is the statement about cytotoxics not working in cycling cells because that's where the antioxidants are being produced. That's actually, I think it's quite clear that some cytotoxics work best and only in cycling cells, and some actually work particularly in S phase. So at least in vitro. Now we could argue whether that's true in vivo, but at least in vitro.
Sure. But I think it's, you know, we're starting with the fact there are a lot of antioxidants there, and how do we kill the cell? And that's why, you know, I like metformin, because somehow it may act in a slightly different way. I think we need something which kills, which is sort of independent of antioxidants. That would be very good. And we don't have anything now. So my objection is just these. it is, the you don't, that you can do good cancer research without knowing anything about antioxidants, I think is good also. They're there. They really cause resistance, and they make lung cancer very difficult to treat. So that's all. I just think that besides the other things we have, and I think now, my chief, gripe with the cancer community is they're not trying really to cure cancer within the next 5 years. It's really relaxed. It's always, we're going to have great things 10 years from now. 10 years from now, I'm going to be senile. I can't enjoy it. I want to have things we want in 5 years. And I think the general public is really only going to give us enough more money when we really cure some cancer.
Well, that might be the flip side. You mentioned the MIT model of getting the scientists away from the patients, but here we encounter the patients every day. So the one thing I would take slight objection to is I think there is a sense of urgency, especially when we do see the patients every day. I think frankly the problem is we're not smart enough. There are too many things we simply do not know. This has not been fully reduced to an engineering problem where you know exactly what needs to be done and you're ready to marshal the forces. I think we're still in a transitional period where we've learned a lot, but we still unfortunately need to learn a few more things. We need to learn how to drug the undruggable, for example, and have people like Jay teach us how to drug targets we never thought about. But I think there is a sense of urgency in the community, and we certainly have a lot of dedicated, hardworking young people, many of whom are lined up along the walls here. I think they are trying to get it done as quickly as possible. But I think we just need to learn more.
If you had the 10 leaders of the AACR and just line them up, how big that is. Don't look at Saturday. There's no real sense of sensual excitement, and I think we're all agreed. Probably one drug isn't going to work. We have to give them a combination. What the combination is, we don't know. We clearly need something to knock out lead. I don't think it would be by self-sufficient. So if you had, metformin or phosphate, or but we're going to have a number of things. But I think we should just try and organize ourselves so we might have a real victory in 5 years instead of, the FDA is so, we can't get anything done. Harold Harmis is apparently, upset by, I wrote, we have no general of our cancer, war on cancer. Well, listen to Harold, he's an academic, very intelligent, and he preferred to be on his bicycle than, any other place. So he's not really, I said we need a general patent, someone who just brings a few regulations, gets things done, shows that it works. Just find the bureaucrats.
Maybe it's because you're not using the mic.
I'm just saying we want someone to fire the troops. Harold is not. Harold is, responsible because, hold another meeting on RAS. Not even Nick.
Question, right here.
Yeah. So you mentioned you studied zoology as an undergrad. You've done some crystallography in your life, and you have some basic chemistry right up there. You mentioned in your talk that people here are too specific, meaning it should be a bit more general, I'm guessing. In your opinion, what is the best way to approach researching cancer?
Find out what causes it, why your current treatments don't work, and find some way just to do it. And, I think I opened it, and, I think we've made enormous progress with the picture. It's cancer therapy which frustrates. Cancer research has gone very well. I mean, it's been an extremely interesting and productive field. But it's not, people don't quite see the need that we're going to have to, it's so nice to say that we made real advance against lung cancer. We haven't done anything in 4 years as the war started. Yeah, that's just so. If I was the general, I'd get things done. I'd get fired, but as long as you get something done, they expect to be fired.
Right. What advice would you give to a young aspiring scientist who would like to become like you?
What advice do you have for a young scientist who would like to be like you?
I'd say work in a lab of someone under 40. Because he has enough time to actually talk to you. And do something different. Just pick out something important. Early in my career, I was doing some experiments at Penn State, one of the big careful. And he just looked at me and says, "That's unimportant. It doesn't matter if that experiment is never done. So don't do something that doesn't matter." I certainly learned a lot about, what my teachers thought was important. So first you have to be very good teachers. And then, lucky enough to be in a lab where something real is happening. Ironically, my PhD thesis was on the indirect effects of radiation. Basically, it was hydrogen peroxide. And I don't think anyone ever, I wrote 2 papers, I don't think anyone ever read it. And it was a waste of time to read that. But there was an interval in which I sort of learned what was good and bad, and then my first postdoc career, I did an experiment, turned out, could have given an interesting answer. It gave a dull answer. And then I saw the X-ray photograph of DNA and decided, that you had to go directly. So you got to ask whether, the problem is chemistry or what you do. Right now, most of the things that are known the immediate, result of my, being hit this meeting was with awful glucoses. But, so I'm on the protein diet for 5 days ago. Because, eat as much fat and protein as possible. But meaning no white bread. It's very bad. With frontline cancer, potential cancer frequency by 20 or 30%. But metformin might do the same thing without my having to be on the Atkins diet. So actually, worrying about our diet is pretty important. And, some people say, starvation before cancer therapy should be done, and additional papers say it's more effective. But, I've never seen an honest review of the subject. But it sort of makes sense to think evolution, it's only recently we had sugar in our lives, and now we give us sugar in everything. But I haven't played, really tried to play tennis since I I fear the worst.
Other questions for Jim?
So, and thinking about, well, what's the most important problem? Curing incurable cancer. That's what we've been trying to do. Cure lung cancer, period. It killed my heart. My wife's mother, so bad stuff. Okay,
Dr. Watson, thank you very much.